Welcome to this video, and whenever you're watching it, you should be proud of yourself because we're finally moving to the last procedure of Unit 6, which is 2 proportion z test. And before we jump right in, I want to walk through a 2 proportion z interval question with you guys because I think those are the content that we covered in the last video, and a lot of the details and the way you format your words is going to be very similar to the thing that we're going to do in this video later. So I think it's going to be necessary to do a 2 proportion z interval question before we going to a more complex one. Okay, so no more talk, let's go into the question. A streaming service wants to compare the proportion of users who binge watch an entire season of a show within 1 week on 2 different devices. In a random sample of 200 users who primarily watch on their phone, 117 reported binge watching an entire season within 1 week. In another random sample of 240 users who primarily watch on a smart TV, 132 reported binge watching an entire season within 1 week. Construct a 90% confidence interval for the difference in the true proportions of binge watchers among phone users and smart TV users. So, first of all, identify P's. You might be guessed, there's 2 P's in this question. And we're gonna define which one represent what. So, first of all, P1, this will be the proportion of phone users who binge watched. P2 will be proportion of smart TV users who binge watched. Simple as it is. And then moving on to naming the procedure and checking conditions part. What is the procedure that we're doing in this case? 90% z interval for 2 proportions. Remember, you state every details right here clearly to really let the graders know what you're doing. And checking the conditions. We're doing a 2 independent simple random samples, and that's true in this case. And we have to also make sure the sample size is less than 10% of the whole population, which in this case is also true because more than 2,000 phone users and more than 2,400 TV users. And then we're going to check NP and NQ. Since we have 2 P's, P1 and P2, they both have corresponding N's. So N1 P hat 1 and N1 Q hat 1 is going to be those values, which has been already provided in the question. Because the question already given us the value directly, we don't really have to first convert it to percentage and then times the sample size. That will be redundant. I think the best way is just going to be pull the values out from the question as stated right here, which is as what we've done right here. So then all of those values are greater than 10, which means we can draw the conclusion sampling distribution of differences is approximately normal. Remember to include approximate right here. And every conditions has been checked. We can moving on to finding the standard deviation of the difference. So remember, because we're using 2 proportions and comparing them, so the good way is to finding the difference of those 2. And we're starting with the standard deviation, which use the percentage of the P1 hat times the percentage of Q1 hat. And how do I get those values? It's right here. P1 hat is going to be 117 divided by 200, and Q1 hat, you can just use 1 minus this value, which will give you this value right here. Same as P2 hat, those 2 values, and use those products divided by each sample size, which will be 200 and 240. And then sum them up, take the square root, you will get 0.047 as the difference of standard deviation. And then what you can do is use the formula to find the intervals, which we talked about in the last video, is P1 hat minus P2 hat times z interval times the difference of standard deviation we just calculated right here. And you will get this interval right here. Or you can just use your calculator, go into stats and test, I believe. I cannot remember the numbers, but you can just do it on your calculator too. It's a more convenient way. But if you want to show your work, what I just said is going to satisfy all what you should have. So then we're going to conclude what we've did. It's going to be, I am 90% confident that between 4.3% fewer and 11.3% more phone users binge than TV users. And that's all. That's all we did. all we have for this question. And this is just a little recap for last video. We're finally moving on to the real part. So how to conduct a two proportion z-test. For most of the parts, it's going to be very similar to two proportion z-intervals, but the calculations part is quite different, so I really want to make sure I'm going to be really emphasize that thing. But first of all, using this example right here, suppose a simple random sample of 160 valid Christian students finds 62 ready for college. I'm not sure what that is, maybe a test or a survey or something, I don't know. And simple random sample of 158 Cherry Creek students finds 95 ready for college. Is this sufficient evidence to conclude that a greater proportion of all Cherry Creek students are ready for college? Test at the alpha equal to 0.05 significance level. Okay, after reading all of those questions, I personally summarized a exam tip for you guys. I'm not sure if that's going to be helpful or not, but whatever the question states in alpha level, that's a hint for you to use test. If it gives you a 90, 95, 99, 98, whatever the confidence interval, it's going to be an interval. So that's a little hint that I used myself every time for FRQ. Okay, so going back to this question, the first part is going to be identify which two, first of all, how many p's do we have in this case? Well, you maybe guessed it's going to be two proportion. Because it's two proportion, we're going to have two p values. I mean, not p values, but 2p. We're going to have a lot of p's in here, so I don't want to be misunderstanding something, so we're only going to do two p's right here. State what each p represent. So a p sub v right here, this is the proportion of valid students who are ready for college. And p sub cc is going to be proportion of Cherry Creek high school students who are ready for college. And one difference of z-test with z-interval is going to be, we're going to identify null hypothesis and alternative hypothesis, just as we did for one proportion z-test. So null hypothesis is going to be, well, this is just the statement that it's not what we think it is true, but it's already been set up, which is the two proportions are equal to each other. And what we think is also you can pull out from the question, because the question are asking for, can we conclude that a greater proportion of all Cherry Creek students are ready for college than the valid students? We can draw the inequality right here, which is p sub v is less than p sub cc. Or you can write in this way. I personally prefer this way because when you're actually doing later in your normal curve, you're going to shade the region. It's better for you to have a boundary value for you to shade the region. Or you can definitely keep in this way also, but just for me, I think it's going to be more clear. And all of those are equal to each other. They are equally amount. So this is all for first part. Moving on to the second part. The procedure that we're doing is two proportion z-test. Remember to state the alpha level 0.05. Checking conditions, we have two independent simple random samples, which is true. And the sample size is going to be less than 10% of the whole population. It's also true, more than 1,600 valid students and 1,580 CCHS students. So then we can draw NP and NQ. But remember, be careful. What will be the value of P and Q we're going to use? We cannot just use whatever the P value from CCHS or valid students, because that will just not be correct, because it will lead to bias, and I'm not sure, since we're doing the difference of two proportions, we want to make sure that we include all of the proportions equally amount. So then what we going to do in this case is to set up a pooled p hat. And how we get this value? What you can do is, from the question, we have 62 valid students. So 62 plus 95 CCHS students. who are ready for college. Those are all of the students from each survey, I mean not survey, but experiments of 2 schools that have students ready for college. And we're also going to add up the total number of students involved in this experiment from 2 schools. And after doing this this whole thing right here, we're going to get a pooled p hat be 0.494. This is going to be the p-value we're using to test if NP and NQ all greater than 10. And how we get the Q, just use 1 minus this value. And we're using Cherry Creek students in here first, so use the sample size of Cherry Creek students times the pooled p hat. And same thing for Q hat, we get those 2 values which all greater than 10. So then we can simply draw the conclusion that Valor students also have NP and NQ all greater than 10. Why? Because Cherry Creek students, the amount of students who are involved in this experiment for Cherry Creek is going to be 158. And the amount of students who are involved in this experiment for Valor Christian students is 160. Because a smaller sample size already have NP hat and NQ hat greater than 10 for each, it's safe to us to draw the conclusion that for Valor Christian students, it's also going to be greater than 10 for each. So during the exam or test, if you run out of the time, you can just safely say also NV P hat and NV Q hat all greater than 10, because the grader will know that, okay, this is already a smaller sample size and it's already greater than 10 for each. It's safe for us to do so. So after doing all of those stuff, we can finally draw the conclusion that sampling distribution of difference is approximately normal. If you forgot to include of difference right here, it's fine, but it's better to add this on. It's not a big deal. So just like what we did for z interval, we're going to do the standard deviation of the difference. It's quite similar with the last question what we've did, but it's also different because we didn't use the instead of use the p hat and q hat for each proportion, we're going to use the pooled p hat and pooled q hat, you can call it, for each proportion. So you can see the numerator of these two are all the same, but they have different sample size, right? Because for this question, they have different sample size. It can also be the same sample size if your question have given to you the same amount of samples for each proportions. Otherwise, it's just going to be represent for each proportion. So taking the square root of those two, summing up, you will get the value is 0.056. This is the difference for standard deviation. And moving on to the calculations part. This is different with what we've did. First of all, stating again for all of the p's what we've known right here. I know it's kind of messy right here because we have a lot of p's. Make sure you don't confuse for each. P hat v is going to be 62 divided by 160. P hat cc is going to be 95 divided by 158. Remember, those are all of the values given in the question. And you will get these two values. P hat, this is the pooled p hat, which is 0.494, we just calculated. And the values in here, this is where you're going to use the p hat Valor student, like the proportion of Valor students minus the proportion of Cherry Creek students. Because we're using this difference for standard deviation, there's no reason for us to not doing the difference for proportions when we're doing the normal curve right here. And you can also do p hat cc minus p hat v as long as your alternative hypothesis is alternated with what I have right here, because you have to be consistent with what you wrote at the beginning with what you drew the conclusion at the end and the calculations you did in the middle. So remember those things. This is the peak. This is the normal curve we did right here, and remember label the standard deviation. This is the value we just did right here, and this is the 0 in the middle. And remember to calculate the z-score and p also. P-value, you can also do it on your calculator if you want. It will be much easier to do it on the calculator. For z-score, you will just use the negative 0.214 we did just in here, minus the 0, because 0 is kind of our mu. Instead, we don't usually do mu in here. This is just the p. And divided by the standard deviation, you will get negative 3.81 for z-score. Z-score and p-value are always going to be included in the calculations part whenever you're doing like z interval for 1 proportion or 2 proportion. So those are all for part 3 calculations. I know it's a lot, but yeah, it takes practice. So last but not least, draw the conclusion. Since in here we calculate the p is pretty much equal to 0, it's so small that we can save to put a kind of like a waving sign right here, equal to 0, approximately equal to 0, and less than alpha equal to 0.05. We reject null hypothesis, meaning we say the proportion of valid students who are ready for college is less than the proportion of Cherry Creek students. And that's all for this question. And when you're actually doing the AP FRQs, there will be a high chance that they will asking you not only to do the complete procedure, but also asking you, okay, what is the type 2 error, what is the type 1 error? For this conclusion you just wrote, what type of error will be most likely be made, and what does p-value stands for? You know, what does 95% confidence interval stands for, and if it gives you a random percentage, and asking you, like, you have to make sure that if that value is lied in your confidence intervals. If it's lied in your confidence interval, then we fail to reject the null hypothesis. If it's lied outside your like not confidence interval, I'm sorry, but the interval that you just calculated. Like for example, like the question in here, this is the interval that we just calculated. If the question asking you, okay, what is the like how about I give you 2%, and asking you, do we save to conclude that will the value like based on the value I just give it to you, do we reject the null hypothesis or fail to reject? Well, because 2% is lied outside the interval, means we reject the null hypothesis because it's like outside the interval. If it's inside the interval, then we fail to reject. So those are just like kind of the questions that you will mostly be asked in your FRQs or like some exams or tests or quiz. So just make sure you study for those, and this is the complete procedure for 2 proportion z test. And so far we finished everything for unit 6, including 2 proportion z test, 2 proportion z interval, 1 proportion z interval, 1 proportion z test. So make sure you study for those, and don't forget the mean stuff. Okay, those are kind of like the lost entries things, but also remember to do this, even though AP FRQs will most likely be asking you proportions related questions, but also it's not a bad thing to master both. So that's all for this video, and thank you so much for watching. I hope you have a great day.